This is webinar number 30. Yeah, I've done 29 webinars so far, and this one is going to be about lazy loading in the object-oriented world. I will show you some Java examples using the Cactus open source library, which we created over the last few months. But the main point now is to demonstrate how lazy loading can be implemented, not to advertise the library, because you can implement the same code, the same functionality. I'll show you. You can do it yourself without the library. The point is to discuss basically three object-oriented ideas and see how they can be put in life through the code. It's going to take about an hour, maybe a little bit less. I hope you can hear me and you can see me. So let's go. I will start with the here's my class, which we will modify now. I have a class. It's a real code, real project. It's called JPEG, and I have a real class which is called statistics. What it does, it encapsulates an XML document, and it creates some additional. It modifies this document and makes it bigger by adding more elements into it. So if you look at the unit test, then it looks like this. I have, let me show like this. So let's say I have an XML. This is XML document. I'm using, by the way, I'm using this library, which you can also try to use, which basically helps you to create, well, helps you to read XML documents. So here's the document. And then it's quite empty. It just contains one single root element. And I want this class to add something else on top of that document. So I create new statistics, I encapsulate the original document, and I say dot value. So I actually call the method which is supposed to do something with the document. And then I check that the result actually contains this path. So you see, before we didn't have it here, and then after the dot value execution, we have a bigger document which contains more information like that. So let me put something here, to fail the test, and you will see what's in the document there. There you go. So it was just metric, but after the class statistics, then we have this one more element with the sub elements. They contain some additional information. Works perfect. If I remove the 9, then the test will just work. There you go. And this class has a problem. It's not a perfect object-oriented design, and now we will make it perfect. What's not perfect? First of all, the bigger problem is the design of this class is that it encapsulates the XML document, and in a right object-oriented world, the right design would be for this class to become an XML document. So it was an XML document which was small, and then I decorated in this statistics class, and I wanted to become a bigger XML document. Instead, it's more procedural right now, so I encapsulate the original one, and then I call this method value in order to retrieve the produced one. So the way it's called here, look, new statistics dot value. It is procedural because of the call to this method. So in the right ideal world, object-oriented world, it should be like that. It should be, here's the XML document, and then it's a bigger XML document. It's still an XML document. I don't need to call anything. I don't need to be, I don't need to make imperative, explicit instructions of how to build the document, of what needs to happen. I just I just construct the object from smaller one to bigger one, and it becomes an XML document. That would be the right object-oriented design, I believe. And it's not like this now. So to make it like that, I need to get rid of this. That would be good. Well, the good thing is here is that XML is an interface. So yeah, if you look here, I can do it like this. I can say implements XML, because XML is an interface from the library I mentioned. It contains just 5 methods, and it's from JCabby. So yes, so here it is. Yeah, it's public interface. It contains 1, 2, 3, 4, 5 methods. So we can, we can say implements XML. But in this case, we will need to have 5 methods in here. 5. See? Instead of 1, I will need to, implement 5 of them. And now they're just placeholders, unsupported operation exception. So it's not going to work, of course, and this is actually how this entire calculation is happening. So now the question is where to put this functionality and what to do, what's the next step. So we got through the first point, right? So I hope you understand that in most cases, in the majority of cases, we should try to get rid of implicit method calling and make our classes and turn our classes into aggregators or decorators of smaller objects. So we had a smaller XML document, now we have a bigger one which decorates the smaller one. In this case it's a decorator because it's just an XML and then an XML. It could be a bigger something. It could be XML plus some extra parameters, some other extra objects. So it could be a few objects, and then a bigger one, aggregate them together, behaving as an XML again or as something else. So that's in general, that's how I understand it, the right object-oriented design, where we are gluing together smaller things, making them, turning them into bigger ones. So like it is happening in this case. So we have a small one XML, then we turn it into a bigger one. So let's see what we can do with this code. So it seems that when the smaller XML comes in, we have to do the manipulation here. We need to produce a bigger XML document, the result one, and then we need to store it somewhere, because look, we have 5 methods. We need these methods to work on something which is ready for us. So the most primitive way would be to take this out. We don't need this method anymore. And say, instead of original, you see it was original before, now we're saying the XML with statistics. Let's call it output. It's the output we are ready to return. And then here's the constructor, and in the constructor, with all this stuff, we do, I don't know why it's, I guess it's like this. Yes, I was right. So we're getting XML here instead of, so we're saying XML here, XML there, and instead of return like it was before, we're saying this output equals to this. Now we have, the moment we construct the statistics object, the output is ready. You see it's gray now because we're not using it anywhere, so we need to start using it. What we do here is we say this output, and we basically I don't know what's the right word, probably delegate that calls to the object we just constructed. Here we say nodes. So I'm not doing anything special. I'm just going through directly to I'm just doing, you see what I'm doing, right? Basically, would be great if Java would, do it for me automatically, but this feature doesn't exist here in this language. I've heard Kotlin has that. So that's it. It seems like it should work. Let's go to the test. And now you see we don't have this dot value anymore. We just had a small XML document. Now we have a bigger one, and it should produce the XML we want. Let's run it. No. Oh yeah, we have some other pieces in the code which also had that dot value somewhere. So this new statistics, oops, sorry, here. Yeah, because I had this, you need to change it everywhere, not just in the test. So it's statistics, but from the statistics it's an XML document, so we need to convert it to string. The statistics, the final one. Wait, statistics is an XML document. Yeah, that's right. So we need to override the toString as well, so that it converts just like that. Let's run. Yeah, so now it works, and what we have here is that this one is an XML document. This one, so I can do the XPath here, you see, directly from this document, when before it was necessary to do this. So first it was necessary for me to retrieve from the statistics the actual document and then do the manipulations. So this class statistics was a holder, a container for the XML document. Now it is an XML document. That's a big difference. So I would say that before, this dot value was sort of a getter, not a getter in a primitive way like it's done in these data classes, but it was close to a getter because it was returning something, assuming that this class is just a holder or maybe a builder of some data or of some other object. So the statistics, the right name would be this before, when we had that dot value method, and the dot value would be, the right name would be build XML, something like that. So that in the past, that would be the right names, which is ugly, of course. You understand, in object-oriented world, we're not supposed to have any builders, and we're not supposed to have any build XML methods. So if we have that, and we had that before, that was a clear, obvious indicator of of a wrong design. Not object-oriented design, let me put it this way. Maybe it's okay for somebody, maybe it's okay for some applications, but this is not what object-oriented thinking is telling us to do. So now it's way better. Now it's perfect. Now it's statistics. We can call it even XML statistics or XML with statistics. That would be the perfect name for the statistics class. Maybe let's rename it actually. Let's say it report with statistics. Yeah, that's the right name. So now we had report. Report is the XML document, and then report with statistics is a report with statistics. It sounds perfect now. It's not perfect. It's okay. It's the first step. Let's make the next step, because it's not perfect yet. It's just the beginning. Exactly. We have a comment right now in the chat, and somebody is saying, so didn't you recommend before not to put any logic in the constructor? That's exactly my point, my next point. So it's not a good idea to have this logic in the constructor. It's not a good, it's a bad idea to do all these manipulations inside the constructor. Why? It's kind of a sort of a philosophical question, maybe it's less technical, because I can't really give you a really strong technical argument for that. But a philosophical argument is that the instantiation of objects and the work of them, the life cycle of them, have to have separate timelines. In other words, first of all, you construct all your objects and then you let them work. While in this case, if you look at in the unit test, so in this case, if I say this, look, and then like this, then the actual manipulation, the actual construction of the XML document will happen here. So even though it's wrong, so in the perfect world, we have to have part 1 construction, part 2 life. So we prepare, we construct our objects here, and then we let them live. We should not mix that two things together. We should not do any actual execution of anything during the construction phase. So this construction phase has to be really quick. It should happen immediately. All the objects should just create everything, not validate anything. No matter what we give, they just build everything, prepare everything, and ready to go. If I say here, if something, I don't know what, happens, then I throw an exception, then I don't need any manipulations to happen. I don't want the XML object to be built. But in our code right now, it will be built because everything will happen here. Even though it's counterintuitive, I don't expect any real manipulations with the data to happen before I call this method. Even though it happens. So this design is wrong. So we are not supposed to have any code inside the constructor. So what can we do? So how can we solve that? We need to build that XML document, and we need to store that XML in the attribute output. So where do I put it? Like what's the solution? Well, the traditional, if you go on Wikipedia and read about it, you will find an article about lazy loading. That's the idea. That's where I'm getting to. It's called lazy loading. So we don't want to to calculate everything until one of those methods are called. So when somebody calls toString, that should be the moment when we calculate the output. But I cannot, put this many, like 50 lines of code in this method and then in that method and here and here and here. Because there are 6 of them. But I want this attribute to be calculated only when this method is called. So what should I do? How can I solve it? How can I make sure that they're 6 times, and then traditional way is to do it this way. That's what you can read on Wikipedia. If you go there, you can see the article, and that's how it should be. You create some private methods which you call output, and then you save here the input, the original one. So you encapsulate the original one. I hope you follow. See? So I encapsulate the original one. I sold the original XML. And then instead of this output, I say output. So remember, what I'm doing right now is horrible. It's terrible, but this is what Wikipedia will recommend you. So don't do it. Just watch me, but don't repeat it. This is not how it should look. Not at all. It's wrong, but it will work. So I created the method output, and it will build the output on demand. The problem is that it will build the output on demand every time I call toString. So every time I call this method, it will do the data processing. It will call this 50 lines of code and rebuild. It's not effective. So this is not what Wikipedia suggests, but this is what Wikipedia will tell you. So what you do is you create one more attribute and you call it output. This is output, and you say it's null. So when the object is constructed, this is null. And then here, and we rename it to not the output, but let's give it a more or less okay name. Okay, again, it's a wrong code, but we'll do it. So we call it build. So we build the output, and this is what happens here. If this output is null, then we do all this stuff. This is called lazy loading. Again, what's happening here? The output is null when the object is constructed. So initially what we do only, well, we can move it here to make it more obvious. So when the object is created, then we encapsulate the original XML, and then we set null to the output, giving like a marker the information for all of these methods that we haven't done the processing yet. So the data is not ready yet, and they will know that they need to work on that and create that object. All of them will know. You see, we call build everywhere. And then the build method will say, okay, is it null? If it's null, it creates everything, saves the output, and returns the output. If the next call, we call it one more time, then the output will be not null and it's not going to be called. Let's put some logging here. See, calculating, and let's go to the test and say we create the XML, and then we call XML toString. Okay, we can call something else. XML, we check the XPath, and then we do the node. You know, I'm just calling different methods. So let's run and see how many lines we will see in the log. I hope just one. Yeah, you see, just one. It doesn't matter what, well, okay, if it matters. XPath, yeah, it failed here, so let's run. See, only once. So it called calculating only once. It loaded the whole thing in a lazy way and did it only one time. This is pretty classic example of lazy loading, but it's ugly for many reasons. Well, for main key reason is because of this thing. Null is something we should avoid in object-oriented programming at all costs. It's a really bad practice, even in this specific case. When I write about null and how bad it is, sometimes people tell me that there are situations where null can be used because sometimes it's pretty well justified to use that technique because this is justified. Look at this example, it's okay. And you also understand that you know, to make it more stable, that would be good to make it synchronized. That's obvious, right? So if the method is synchronized, then because if it's not synchronized, then this whole class will not be thread safe. So to make it thread safe, we need to make it synchronized so that if multiple threads at the same time will call different methods, then we will calculate this thing again and again. So null is bad. Even in this case, even if someone will tell you that it's justified, it's not justified. Just when you see null, don't do it. It's wrong. And this is wrong. Look, we have an attribute which is not final. This is horrible at all. All attributes in all objects, they must be final. That must be the rule the really unbreakable rule. I even in one of my presentations, I said that I was mentioning the keywords in Java, which in my opinion are making the language less object-oriented. And I put all the different keywords on the slide, on the keynote slide, and one of them was the keyword final. So that was the keyword final. And then there were other keywords like extends for implementation inheritance, like null, for example, like many of them. And then I asked the audience which keyword you would like to discuss, and everybody said final. So, and that was my next slide, the final slide, because I was expecting that reaction. I was expecting people to react that way to the final keyword, and because they didn't understand what's wrong with the final keyword, they think the final is a good idea. And I also think it's a good idea. What I think is that the existence of this final keyword is a bad idea because everything should be final. Everything. So the final keyword gives us an ability to make something not final. And that's something which makes that object mutable in a bad way, and makes it possible it provokes us to treat that object as a storage of data. Look, it is a storage of data. It is very procedural design right now. We keep something which is an input, and then we use that temporary storage for something which we will return later. So we use our internal kind of a memory space, but not a memory space. It's like our internal, in our internals, we use it as a temporary storage for something, which is not how an object should work. An object is not a temporary storage for data. Yeah, there is some comment. Someone is saying that the proper name would be lazy initialization, not lazy loading. Well, yeah, maybe you're right about that, because I'm not really good on this naming, like lazy loading, lazy initialization. Because yeah, I've read on Wikipedia some examples for the classic lazy loading, and it's more like some object which initially is completely empty, and then you start touching it, and it goes somewhere to the database and it loads something. I don't know what, but in this example I see it as a lazy loading, but maybe it's lazy initialization. I don't know. Yeah, and there's another comment saying that now we have a side effect that the first call of any of these methods will take some time, more than all next calls. That's true. Yeah, so every time the first call will take some time, like toString will take time, and then all other calls will be way faster because they will have the output ready. That's a kind of a side effect which obviously is there. So now the question is how to make it better. What's the right design? How to get rid of this null? And I'll show you now. So here's what I would do using Java 8 lambdas. I would say the XML with statistics. I'm coming back to the original, to the right naming. I call it output. I remove this, and it's not the output, but I call it scalar. Scalar is the interface, as they call it now, functional interface from Cactus, which is really primitive. It has just one method value. Just one method, nothing else. It's really primitive one method interface. And output equals to, and then I get all this code. And I put it here. See? So output now is a function, a functional interface, which will work like that. I guess this ID has some text replacement functionality, but it's already done. Why it's red? Because it's the value throws an exception, and we need to get rid of that exception. That's why I will do it like this. So look, the interface scalar, the method value throws exception. This is the way Cactus primitives are designed. So they allow you to throw exception from any place you want, which is I think it's a good idea because it minimizes the amount of this try catch in so many different places. So all the interfaces we have in Cactus, they all allow you to throw exception. But in this situation, it becomes a problem because toString, for example, cannot let the exception float up. So we need to catch it. We can do it this way. Cactus provides this simple primitive. Unchecked scalar, like that. So this unchecked scalar is a decorator which just decorates another scalar, but the method value doesn't throw an exception. So if you click here, it just method value, but there's no exception throwing here. So it perfectly works for us. And we can put this unchecked scalar everywhere, of course, in all these 6 methods, but the better way would be to do it like this. Unchecked this way. Yeah, if we make it unchecked, you see there's no red lines here, but here we need to decorate there you go. So what happens here? In the constructor, the input comes in, we create a scalar, we create a no argument, simple, let's call it function, which builds everything for us and returns. So we solved the problem of the null. We don't have the null anymore. We don't have any additional methods in the class. It's quite clean now. We don't have this build method anywhere, private method. We have everything in the constructor, even though this code is not executed during the construction of the class. And it works. Let's try. It works, but it's going to build our document multiple times. See? Let's run it again. Obviously, because we'll call that method. We'll call that method multiple times. See? 3 times. So it actually created the document, created the that XML output 3 times, which is not what we want. Obviously, we want it only once. Let's leave it here. To fix that, we have another decorator from the Cactus library, which is called sticky scalar. This one is sticky. Why it's sticky? Because it will oh yeah, that's wrong here. Wrong order. So it's unchecked scalar stays on top. So sticky scalar is it encapsulates another scalar, but when we call it, it's gonna return you the result only once. So it implements inside here, it implements the caching mechanism. So here inside the sticky scalar, it's a small array, a small not smaller, a small place, which initially is kind of null, but it's not null inside. It's different implementation there. So it's empty when you start, and then when you call it for the first time, it fills that place with the value. If you call it the next time, it's going to return you the same object which was previously cached. It's a simple caching technique. Let's run and see how it works. Boom, it's only once. Well, for me it looks pretty elegant, this approach. And to make one step even further, it's not thread safe now. So if I call it from different threads, then the result may be unpredictable because this sticky scalar is not thread safe. So it doesn't guarantee you that if multiple threads will call the method value, it doesn't guarantee anything what will happen inside. Maybe it will calculate once, maybe it will be calculated multiple times. I don't know. If you want, we can try and create some small simple unit test which will show us how it works in a number of threads. So let's make it, you know how to write multiple threads tests, right? So we create a service, and then we do for let's do thread idx. Yeah, let's call it thread. How many threads we want? Let's call, I don't know, 50 threads. So I will just, no, it's probably not a good idea. Well, it will work, but it will not reproduce the problem exactly. Why? Because we will call this service.submit, and there's a high chance that that's enough. That's basically the test. But if you run it, let's see what happens. So it's gonna call 50 times. Boom, boom, boom. I don't know how many times that boom happened here actually, but we can calculate. But many times. Many times. Yeah, you see, which is wrong because it's sticky scalar, you see? So it's supposed to be only once, but it happened not 50 times, of course, but many times. So this boom, it is supposed to happen only once, but it's not, it happened more than once because we did it in multiple threads. But that's not really a good approach to create multi-threading tests, because the timing between these submit methods, so you call submit, and there's a high chance that everything will be finished before the next call to the submit. And you're trying to create a multi-threading test. We need to shut it down. Even though you're trying to create a test which will put multiple threads on your object, in this particular code, it may not actually do what you're expecting to do. It may go one by one. It may run them all sequentially, not in parallel. It's a high probability of that. So the right design would be to do it this way. There's a thing which is called countdown latch. You probably know what it is. So we create a countdown latch, and then we do latch wait. So it is callable. So we're gonna wait for this latch to become available. And then we do latch countdown. So what happens here is a pretty classic example of multi-threading, you know, of testing something for multi-threading. So what will happen now, first of all, we will submit 50 different 50, or not equal, not different, but equal 50, we will create 50 threads, and they all will start. This service will run them all, well, provided there's enough space for 50 threads, but let's hope let's do 50. So we create a pool of 50 threads which are empty now, they're just waiting, and then we submit 50 different 50 runnables, 50 pieces of code, and they all start immediately. They start the moment we call submit. So we call submit, it starts. We call submit, it starts. We call, it starts. So the last one will be called the last. The first one will be called first. But none of them will actually do this one, because they will all be stuck at this line. They will all start and will be locked on this latch, and will wait for the latch to go down, because there's one counter in here, and they will all wait for the zero, the number 0 over there. And then we say countdown, so we put 0, and all of them 50 immediately start to work. Well, not immediately, of course, because I have just only 8 CPUs, but 8 of them will start immediately, and then all of them will start more or less immediately. Let's see how many of these boom signs, boom text we will get. Boom. Many of them. We can actually count how many. How do I count how many? I guess it's like this. Yeah, let's run. Yeah, what's the maximum number here? Look, 50. You see? So 50 times. We created that thing 50 times. Even though we get a sticky scalar, but from multiple threads, it doesn't work. Even though we want it to be called just once, from multiple threads, it doesn't work. Let me show you. So if I put just one thread in here, then we will see this boom only once, even though we're gonna call it 50 times. Let's run it. So I predict that we're gonna see the boom line only once, twice. That's a good question. Why do we have that twice? I don't know, to be honest. Should be one. Let's see the comments. Maybe somebody will tell me something. So why it's twice? New fixed thread pool starts. It has just one thread. So in one thread it gets 2 string. And then in the second thread, I don't know, let's run it again. Yeah, it's 2 times. I have no idea, to be honest. It should be once. So it was the second time here. Yeah, but that's the same XML document. It's not, it shouldn't be again here. Ah, there you go. So yeah, that's exactly what happens. So they actually run in parallel, because here we have we start a background thread. I can explain what's happening. So here we start a background thread. We put that line into that background thread. Then we say countdown. It immediately starts to work. Then we say shutdown, but the shutdown doesn't terminate the thread because shutdown doesn't kill the thread, doesn't interrupt the thread, it just let the thread finish. So the thread is running, the XML2 string is in process, and we immediately call XML2 string again. So that's why we have 2 lines. But now we have perfectly 1 line, boom, 1. So that's all right, because if I put 50 here, again, we're going to have 50 of them. It should be 50, almost 50, but in most cases it will be maybe close to 50, not necessarily always 50, because yeah, see, it is 50. But if I remove this latch weight, then we will see way less of them, like I just explained, because some of them will finish before we call the next submit. So if I remove that synchronization by the latch, then this multi-threading test will not run to its full potential. Some of the threads will go sequentially instead of being parallel. So let's run and see. We will see less lines now than we saw before. We're not going to see 50. See? So we see like, and they go sequentially. See, 1, 2, 3, 4, 5, 6, 7, 8. So now they go one by one. When before with the latch, they all go parallel and in no predictable order. So using this latch technique is what you're supposed to do when you want to test your object for thread safety. Okay, how do we solve that? We still our object want to be thread safe and don't do this boom boom so many times. So there's another decorator which we have from Cactus, which is called sync scalar. So that one will be synchronized. So that's another one which we decorate our sticky scalar. We decorate it with a sync scalar, and the sync scalar make everything thread safe. So if I run it again, same test, we should see only 1 line. There you go. So now we're perfectly fine. We have everything you need. And there's another good thing in Cactus library. We have solid class, which is both sync and sticky. Not stinky, sticky. It is called solid, meaning that it is at the same time and synchronized and sticky. Let's run it again. It's a pretty new library, but it's pretty stable. I'm using it in multiple projects already. You see, it works perfectly fine, and that's how our code looks. Unchecked solid scalar. We create the scalar, and then it just works inside. That's all I wanted to show you. I use that technique in many projects and many objects and many projects, and I keep using it more and more frequently. I find it really convenient because on the surface here, my object looks just perfect. Look how beautiful the design is. Report with statistics and then the XML inside. So I don't need to. I can perfectly get rid of all the procedural things I had before. I can really create bigger and bigger objects, and when I need them something to prepare for them to work, when I need some processing inside, I can just use these scalars inside. That's all I wanted to show you. Yeah, that's a good comment about the code. Thanks for that. I already figured it out. Yeah, that's pretty much it. Even inside the Cactus library, there are many places where these scalars are used. We have scalar, we have function, which is a bit more complex thing because scalar doesn't accept any argument. You see, there's no argument here. We have also function interface, which is called like this, and then it accepts something on the input and something on the output. And we also have synchronized functions, and we have sticky function, we have solid function, we also have by function, which accepts two arguments, and returns one argument. Also, we have sticky by function, and we have synchronized by function. So that's basically the primitives which help me to design my objects in a better way. So this one is the design I like. I actually I'm ready to commit it, and this one is too long. But I can't do anything with this line. This one I can fix. I want my lines to be 80 characters long, and that's it. That's the code I wanted to show you. Boom, like this. That's it. I will run the entire test now and contribute it and commit it to GitHub. If you have any questions, feel free to ask. I think it's quite obvious. Yeah, there are some Q questions. There's a comment saying that the problem that you have to write all this protection against multi-threaded initialization, but instead you can put all this initialization logic without wrappers into constructor. And then it doesn't matter how many threads are trying to call methods of the object, as it's already fully initialized. Yes, of course, if we put all that code into the constructor and let the object create everything during the construction, then yes, we don't need this protection against multi-threading and everything. But like I said before, philosophically, I believe it's really wrong to have any code in the constructor which is executed when you start an object. I even have an article about that in the blog, and I have a chapter in the book about that. I try to explain why it is, but I don't have a technical strong argument saying that this is better. It's more like philosophical segregation of initialization and the life cycle of an object. I believe it's really important to split them, to keep them apart. If you mix that, it will be difficult. Maybe it's another argument. It will be difficult to trace the errors. It will be difficult to understand why your objects fail when they fail, and when they fail. They're not supposed to fail during the construction phase. They can fail when you actually start working with them. That's the right moment for failure. That's where you track the exception. That's where you catch the exception. You're not supposed to catch the exception when you're just building an object or all your objects. So that's it. That was quite practical webinar. I hope you can use that library. I'm using it everywhere now, like more and more. It saves me a lot of time, and it's pretty well tested. It had some synchronization issues before. We fixed many bugs which we had before. Now it's pretty stable. All these scalars and functions and bifunctions, they're pretty well working and being used in different projects. So thanks for watching. I'm ready to finish. See you next month, the first Wednesday of each month, 11 in the morning Pacific time. Thank you. Happy coding.